Hi, I'm Tim, and my co-founders are Yao and Song, and together we are Kova. As Kova, we're using AI to bridge one of the world's largest health disparities by transforming the treatment and diagnosis of sickle cell disease. So I'll start today's pitch off with a little bit of a story. It's 2015, and my co-founder Yao had just graduated with his MD from Ghana. He had a patient come into his office, Futi, who was in excruciating pain, is freaking out. So Yao consulted with his fellow doctors, and they're like, okay, it seems like Futi probably has sickle cell, but we need to run a diagnostic test to make sure so we can give Futi the right treatment. But the problem was, Futi's family just couldn't afford the diagnostic test. It was too expensive for them. And because of that, Yao and his fellow doctors weren't able to give Futi the treatment that he needed. And the fact of the matter is, Yao wasn't the only person that experienced this as a physician. There's actually 170,000 children that die each year because they can't afford the diagnostic solutions for sickle cell disease. Across the world, you have 30 million people with sickle cell, and even in America, where people can afford the diagnostic solutions, you still have people living 33 years shorter, those that have sickle cell versus those that don't, and people with sickle cell spending upwards of 13 days a year in the hospital and about $1 million in lifetime treatment costs, which is huge when you think about it. Sickle cell predominantly affects the Black community all over the world, so there's lots of people in America that have it, and especially across Africa as well. Now, when we're talking about like what is sickle cell and how does it work, you have the normal healthy red blood cells you see here, but with someone with sickle cell disease, when they undergo stress for one reason or another, their cells can change this sickled shape, and then they clump together and clog in some part of the body. If it happens in the brain, the person will have a stroke. If it happens in the heart, the person will have a heart attack. And if it happens, say, in one of the arms or legs, and it's this excruciatingly painful event, the sickling crisis, that brings the person to the ER again and again. Now, we recognize this is a huge problem, but we also know that we're the team to solve it. We have me doing my PhD at Yale in computer science as a CTO, Song, who recently got her MBA from Yale as a COO, and Yao, who has an MD and is currently doing his PhD in biomedical engineering at Berkeley as the CEO. And together, we are working to make the solution, which is an affordable and accurate AI-based diagnostic and monitoring tool. So we can do both the diagnosis to determine whether or not someone has sickle cell, as well as track the health of the red blood cells and monitor their health over the course of time to prevent sickling crises. So we're doing both solutions in one device. A quick explanation of how it works. You take the sample of blood from the patient, put it into our proprietary cartridge, put the cartridge into the device. The device images the red blood cells to get these 3D images like the one seen here. Those are taken and passed to our deep learning model, which then does the classification for sickle cell, no sickle cell, so you have the diagnosis there, as well as the health of the red blood cells. That's the monitoring component that can be traced over the course of time. Those results are then displayed on the screen of the device to be seen by the healthcare professional and shared with the patient, and have many clinically relevant decisions that they impact. So in terms of how our solution compares to the current standard for diagnosis, current standard takes about 2 days. We're bringing that down to less than a minute, and we're also reducing the cost by 95%. You can also see that we're adding this monitoring component, which the current solution just doesn't have, and which is a huge value add in the American market. Now, as for what we've done so far, we've established key partnerships with the University of Connecticut, with the University of Cape Coast in Ghana. We've done some initial building of our AI models on some data that we have, and going forward, we plan to collect more data in the coming months, which we'll then use to improve our AI models, and then we'll be using kind of these validated results to raise our next round of funding, our seed round of about $3 million, which we'll then use to go from prototype to product, and then going through the regulatory process in America, through the FDA, as well as across Africa. Since we expect the process in Africa to be a lot faster, we'll be able to launch there first with our diagnostic solution, and as we launch, collecting more and more data to improve our monitoring solution so that when we launch in America, we'll launch with the monitoring solution and be able to spread across the country quickly. We'll be selling the device as a one-time sales, as well as the cartridges on a subscription model. You can see this is a huge market with a lot of money to be made, but because our technology is a platform technology, we're not just limited to sickle cell. We can actually expand to other hemoglobinopathies as well, like malaria, thalassemia, spherocytosis, which means there's a lot more money to be made and a lot more lives to be impacted as we expand. We know that now is the time to bring this solution to market with the advances in AI that make this possible and this growing awareness of the world's health disparities, and we invite you to be a part. Thank you very much.